Hi everyone. In this video, we will study how to interface the IR obstacle sensor with the ESP8266. This is the IR obstacle sensor. It consists of one IR transmitter. This is the IR transmitter LED and one photodiode. The IR transmitter transmits the IR beams and the beams are reflected by an object. The reflected beams will be detected by the photodiode. The IR obstacle sensor consists of 3 pins. First one is VCC, then middle one is ground and the last pin is out pin. Based on the object detection, the out pin will be high or low. Here I am using active low IR sensor. That means if any object is detected, the out pin will be low. You can adjust the object detection range by varying this variable preset. This is the circuit diagram of IR sensor interfacing with ESP8266. Here you can see the out pin of the IR sensor is connected to D0 pin of ESP8266 and ground and VCC pins are connected to ground and 3.3 volt terminals or ports of the ESP. Here a buzzer is connected to D1 and ground. The purpose of this buzzer is if any object is detected by the IR sensor, the buzzer will be turned on. Now we are moving to the software side. This program is written in Arduino IDE. Beginning of the program contains two hash define statements, hash define proximity D0 and hash define buzzer D1. First statement, hash define proximity D0 means we are connecting the IR obstacle sensor to D0 pin. So D0 pin is named as proximity, and in the second sentence, hash define buzzer D1, the D1 pin is named as buzzer. Here buzzer is connected to D1. Then into VAL is equal to 0. That means VAL is an integer variable and its value is initialized as 0. Then in void setup function, we have two pin mode statements, pin mode proximity input and pin mode buzzer output. In the first pin mode statement, the proximity pin, that means D0 pin is configured as input port. Then in the second statement, the buzzer pin, that means D1 pin is configured as output port. Moving to void loop function. In the void loop function, the first statement is VAL is equal to digital read proximity. This digital read function will read the status of the pin D0, whether it is high or low, and is assigned to the variable VAL. That means if D0 is high, then value of the variable VAL is also high, and if D0 is low, the value of the variable VAL is also low. Then we have an if else condition. If VAL is equal to low, VAL is equal to low means object is detected. Okay, then if the condition is true, digital write buzzer high. That means if VAL is equal to low, we will turn on the buzzer. The buzzer will activate. Else case, that means if VAL is equal to high, we will set digital write buzzer low. That means the buzzer will be off. This is the source code, and in next section we will move to the original circuit setup. You can access the source code and circuit diagram from my blog notesforinfo.blogspot.com. Write your program in Arduino IDE and upload to the ESP8266. Here I connected all the components in the breadboard. Now we are going to test the circuit. Now I will put an object in front of the IR sensor and let's see what is happening. See, the buzzer is now activated. If you liked my video, please subscribe my channel and share this video to your friends. Thank you for watching.